Namaskar, I am Anand and you are watching Join for Education. In this class, I am going to discuss about projection of a vector. Board examination asks question from this topic. So this is a special topic of vector algebra. Let's see the details about the projection of a vector. Let's see the derivation or details of projection of a vector on a line. Let's see, try to understand what is the projection, uh, what is the vector and what is the line. For this we take the help of this figure. Let's see. So AC is the projection and AB is the vector and L is the line. Let's see what is the AB. So AB is a vector and what is the AC? AC is the projection and what is the line? Then L is the line. This line is also known as the directed line. So we try to find out what is the value of the projection or magnitude of the projection vector of a vector A on a line L. So projection of vector A on a line L is AC, which is generally denoted by this one. So this figure is in first quadrant, this figure is in second quadrant, this figure is in third quadrant and this figure in fourth quadrant. Let's see the written statement related to these four figures. Suppose a vector makes an angle theta with given directed line L, say in the anti-clockwise direction. Then the projection, this one or AC, of a vector on the line L is a vector P with magnitude and the direction of projection vector P being the same or opposite to that of the line L, depending upon whether cos theta is positive or negative. The vector is called projection vector. So this one is called projection vector and its magnitude is simply called projection. So projection, it means that what? Magnitude of the projection vector on the directed line L. In each of the following figures 1 to 4, projection of vector AB, this one, along the line L, it means the directed line, is vector AC. Hope that there is no problem to understand the written statement as well as the figure related to the projection of a vector on a line. Some more about this one. This is the vector A and we try to find out projection of vector A on the line L. This is the directed line which is AC and simply or generally denoted by vector P. Projection, it means that what is the magnitude of vector P. So see here what will be magnitude of vector P, or simply we say projection. So we write down here projection of what? Vector A where on line L equal to what? Then this one is vector A into vector L by magnitude of vector L. So this is the dot product. So the projection, it means that magnitude of the projection vector. So this one will be what? Vector A into vector L by magnitude of vector L. According to the direction cosine, vector L by magnitude of vector L equal to cos theta. Therefore, we can write down here projection of vector A on the directed line L equal to vector A into cos theta. Let's see here, if we put at a glance in the first figure, here vector A lies in the first quadrant. In that case, direction of the vector and direction of the projection, let's see, direction of the projection, it means that AC along the direction of the L or directed line. So direction of the projection along the direction of the line. Here in the second figure, when vector A lies in the second quadrant and theta greater than 90 degree but less than 180 degree, in that case direction of the projection is opposite to that of the directed line. In third figure, when theta greater than 180 degree but less than 270 degree, lies, vector A lies in the third quadrant, direction of the projection AC is opposite to the direction of the directed line. In the fourth figure, when theta greater than 270 degree but less than 360 degree, or vector A lies in the fourth quadrant, in that case direction of the projection AC along the direction of the directed line. So hope that there is no problem to understand the complete details related to the projection of a vector on a line. The magnitude of the projection vector, we say projection. So projection of a vector on a line equal to vector A into cos theta equal to, we write down this one, vector A into vector L by magnitude of vector L. So we take the help of this formula to find out the projection of a vector on a line. So in the question we have what is the value of the vector and what is the value of the line in vector form. Then we have no problem to find out the projection of a vector. Let's see some questions based upon these details. This is the question number 3. In question number 3, ask us find the projection of the vector unit vector I minus unit vector j on the vector unit vector I plus unit vector j. Let's identify here, this is the value of vector A and this is the value of the line or directed line. So we write down here, simply we write down here, let's see the solution. We write down here solution of question number 3. From question it is clear that we write down here from question it is clear that vector A equal to unit vector I minus unit vector j. Vector L equal to unit vector I plus unit vector j. So we find out here what is the projection. So we know that projection equal to what? Vector A dot vector L by magnitude of vector L. So put here unit vector I minus unit vector j dot unit vector I plus unit vector j by magnitude of vector L. It means that 1 square plus 1 square over root. So the next step here will be unit vector I into unit vector I equal to 1, unit vector I into j equal to 0. So we write down here 0 minus unit vector j into I equal to 0. We write down here simply minus 0, and unit vector minus j into j equal to minus 1 by we write down here root 2 equal to 0 by root 2 equal to 0. So the projection of vector I minus j on the vector I plus j is 0. Hope that there is no problem to understand the explanation of the solution of this question. Let's see the solution of the question number 4. Solution of question number. We simply change the sum step in the solution of question number 4. Let's see here. From question it is clear that vector A equal to unit vector I plus unit vector 3j plus unit vector 7k, and vector L equal to unit vector 7i minus unit vector j plus unit vector k. We find out here vector A dot vector L equal to unit vector I plus unit vector 3j plus unit vector 7k dot unit vector 7i minus unit vector j plus unit vector k. According to the dot product of two vector, we know that here will be 7 minus 3 plus 7 it is 56 equal to 60, and the magnitude of the vector L equal to here will be 7 square plus minus 1 square plus 8 square over root equal to here will be 49 plus 1 plus 64 over root. equal to this one will be 114 over root. So we know that we recall the formula projection equal to vector A dot vector L by magnitude of vector L. Now putting the value of, then we get here 60 by 114 over root. So this one will be the answer of question number 4. There are some differences between the solution of question number 3 and 4, and each explanation is acceptable. You can use any one of these two explanation if question asked in the board examination related to the projection of the vector. After there is no problem to understand the solution or understand the explanation of the solution of these two questions. After there is no problem to understand the concept about the projection of a vector on a line. In the next class, I will discuss some more topics related to the vector algebra in the point of view of the board examination, which is going to be held in the coming month. Thank you very much.